B-1B's blended wing/body configuration, variable geometry wings, and turbofan afterburning engines combine to provide long range, maneuverability, and high speed while enhancing survivability. Forward wing settings are used for takeoff, landings, air refueling, and in some high-altitude weapons employment scenarios. Aft wing sweep settings, the main combat configuration, are typically used during high subsonic and supersonic flight, enhancing the B-1B's maneuverability in the low and high-altitude regimes. The B-1B's speed and superior handling characteristics allow it to seamlessly integrate in mixed-force packages. These capabilities, when combined with its substantial payload, excellent radar targeting system, long loiter time and survivability, make the B-1B a key element of any joint/composite strike force. The B-1 is a highly versatile, multi-mission weapon system. The B-1B's synthetic aperture radar is capable of tracking, targeting, and engaging moving vehicles as well as self-targeting and terrain-following modes. In addition, an extremely accurate global positioning system-aided inertial navigation system enables aircrews to navigate without the aid of ground-based navigation aids as well as engage targets with a high level of precision. The addition of a fully integrated data link, FIDL, with Link 16 capability provides improved battlefield situation awareness and secure beyond line-of-sight reach-back connectivity. In a time-sensitive targeting environment, the aircrew can use targeting data received from the Combined Air Operations Center or other command and control assets to strike emerging targets rapidly and efficiently. The B-1B's onboard self-protection electronic jamming equipment, radar warning receiver, ALQ-161, and expendable countermeasures, chaff and flare, system and a towed decoy system, ALE-50, complements its low radar cross-section to form an integrated, robust defense system that supports penetration of hostile airspace. The ALQ-161 electronic countermeasures system detects and identifies the full spectrum of adversary threat emitters, then applies the appropriate jamming technique either automatically or through operator inputs. Current modifications build on this foundation. Radar sustainability and capability upgrades will provide a more reliable system and may be upgraded in the future to include an ultra-high-resolution capability and automatic target recognition. The addition of Link 16 and FIDL, combined with associated cockpit upgrades, will provide the crew with a much more flexible, integrated cockpit, and will allow the B-1 to operate in the fast-paced integrated battlefield of the future. Several obsolete and hard-to-maintain electronic systems are also being replaced to improve aircraft reliability. The B-1A was initially developed in the 1970s as a replacement for the B-52. For prototypes of this long-range, high-speed, Mach 2.2 strategic bomber were developed and tested in the mid-1970s, but the program was cancelled in 1977 before going into production. Flight testing continued through 1981. The B-1B is an improved variant initiated by the Reagan administration in 1981. Major changes included an additional structure to increase payload by 74,000 pounds, an improved radar and reduction of the radar cross-section by an order of magnitude. The inlet was extensively modified as part of this RCS reduction, necessitating a reduction in maximum speed to Mach 1.2. The first production B-1 flew in October 1984, and the first B-1B was delivered to Dyess Air Force Base, Texas, in June 1985. Initial operational capability was achieved on October 1, 1986. The final B-1B was delivered May 2, 1988. The United States eliminated the nuclear mission for the B-1 in 1994. Even though the Air Force expended no further funding to maintain nuclear capabilities, the B-1 was still considered a heavy bomber equipped for nuclear armament until 2007. The conversion to conventional only began in November 2007 under the original START Treaty and was completed in March 2011 under the new START Treaty. To make that conversion possible, two steps were taken. During the first step, a metal cylindrical sleeve was welded into the aft attachment point of each set of B-1 pylon attachments. This prevented installing B-1 air-launched cruise missile pylons. During the second step, 2 nuclear armament unique cable connectors in each of the B-1 weapons bays were removed. This prevented the pre-arm signal from reaching the weapons. The B-1B holds almost 50 world records for speed, payload, range, and time of climb in its class. The National Aeronautic Association recognized the B-1B for completing one of the 10 most memorable record flights for 1994. The most recent records were made official in 2004. The B-1B was first used in combat in supportive operations against Iraq during Operation Desert Fox in December 1998. In 1999, 6 B-1s were used in Operation Allied Force, delivering more than 20% of the total ordnance while flying less than 2% of the combat sorties. During the first 6 months of Operation Enduring Freedom, 8 B-1s dropped nearly 40% of the total tonnage delivered by coalition air forces. This included nearly 3,900 dams, or 67% of the total. In Operation Iraqi Freedom, the aircraft flew less than 1% of the combat missions while delivering 43% of the dams used. The B-1 continues to be deployed today, flying missions daily in support of continuing operations.